Pre-Algebra Lesson 9-2, Experimental Probability. So this lesson is kind of a continuation of yesterday's lesson on probability, and it's called experimental because you know how if you flip a coin, it's supposed to come out about half the time heads and half the time tails. But if you actually do that 100 times, is it for sure going to turn out 50-50? And the answer to that is no. And so they've done some experiments here. They've actually counted things up to see how things actually turned out. And so we're going to do some work based on that, on experiments that have been done. Okay, so our slide here says a machine is filling 50-piece boxes of chocolate candies by choosing at random from a selection of 6 types of chocolate candies. An inspector records the results for one filled box in the table below. Okay, so they told us it's going to add up to 50. And in this particular box, we got 8 dark, 12 light, 6 caramel, 4 dark with nuts, 15 light with nuts, and 5 cream. Okay. The inspector then expands the table to fill the experimental probability. So let's see what that looks like. So his little formula for that, it's just like yesterday's, that the probability of a particular kind of candy is the number of that kind of candy over the total number of chocolates in the box. So they told us that there were 50. So notice all of our denominators here are 50 to start out with. And they just took the 8 for dark and put that there, the 12 for light and put that there, and so on. And then you just have to reduce the fraction then. And again, we're looking for a fraction here, otherwise known as a ratio. So our actual answer there is the reduced form of the fraction. Okay, then they express the experimental probability in terms of a percent. If you were to put in your calculator 4 divided by 25, you would get 0.16, which is 16%. If you put in your calculator 6 divided by 25, you would get 0.24, which is 24%. And so you would just keep doing division problems with your fractions, and that would give you the decimal, which you can then change to a percent easily. Okay, down here, they just want to revisit something from yesterday. The sum of the experimental probabilities, when they are ratios, they've got them all in 50ths here because they're easier to add, and they gave you all the numerators from up here, except for this last one. Oh, the last one is the sum. It's after the equal sign. So if you add all of that up, 20, 26, 30, 45, and 5 makes 50. 50 over 50 equals 1. And that has to be true, that all of the experimental probabilities have to add up to 1. And then down here, they're just showing you that that's true as percents as well, assuming we didn't round any of these percents, which we did not. That if you add up all of these numbers, they're going to add up to 100% or 1 again. Okay, so it always has to add up that way. Now they're asking us to complete the table to find the experimental probability. A very exciting story again here. 5 types of seed are inserted at random in a pre-seeded strip ready for planting. And we don't really even care if we understand that or not. We've got all these numbers here, and we need to know what they add up to. Now, did they tell us what they added up to? Well, actually, they did because they gave us this denominator here. I just want to double check and make sure, though. 40, 140, 220, 280, and 400. So it does indeed all add up to 400. So all you got to do is put these numbers in here. And then you have to simplify the fraction. Let's see, we can divide this one by 40 over 40. That's going to get us down to 1/10. And you can use your calculator for that if you know how to use the fraction key. 100 out of 400 is going to be 1/4. 80, if this one is 1/10, this one's going to be, this one's 1/10, this one's going to be 2/10, or 1/5. And this one's going to be 6 out of 40, or 3 out of 20. And this one will be 12 out of 40, which would be 3 out of 10. Let me double check all those real quick. Okay, yeah, those are all right. Okay, so this first one they wanted as a ratio, and the next one they want as a percent. And you can use your calculator to change these things into percents. 1/10 is going to be 10%. 1/4 is 25%. 1/5 is 20%. This one's 15%, and this one would be 30%. Those were actually all ones you probably should know off the top of your head. Now, if we're going to check and make sure we're right, I'd like to add these percents up. 10, 35, 55, 70, 100. They should all add up to 100. And all of these numbers, these numerators over the 400, should add up to 400. But since all we did was copy them, I'm pretty sure we got those right. All right, let's work a few more problems. Number one, a number cube was thrown 150 times, so that's nice. They gave us the total. The results are shown in the table below. Complete the table with the experimental probability for each outcome. And once again, we're going to express our probabilities in terms of fractions. So we rolled the die, and these are the things that you're able to get when you roll a fair number cube. And then these are the outcomes. And we know that it's out of 150. So we're going to go 33 out of 150, 21 out of 150, 15 out of 150, 36 out of 150, 27 out of 150, and 18 out of 150. I can tell every single one of those is going to need to be reduced. You see the factors of 3 and all of that? And that's kind of painful to have to do that in your head, so just use your calculator and do 33 fraction key 150, and you're going to get 2 1/5. Let's try that again. 33 fraction key 150 equals 11 over 50. Clear that out. 21 fraction key 150 equals 7 over 50. This one's going to be 1/10. And 36 fraction key 150, it equals 6 over 25. 27 fraction key 150 equals 9 over 50. And 18 fraction key 150 equals 3 over 25. Okay, then it says a movie theater. That's a whole different thing here. Let's get rid of this. A movie theater sells popcorn in small, medium, large, and jumbo sizes. So you got to keep track of those. Small, medium, large, and jumbo. The customers of the first show purchased 4 small, 20 medium, 40 large, 16 jumbo containers of popcorn. Find the probability of the purchase of each of the different size containers of popcorn. So the probability of small is going to be 4 out of what? Well, they didn't give us a total. So we've got 4, 24, 64, 74, 80. 4 out of 80. We'll come back and reduce later. Medium, 20 out of 80. Large was 40 out of 80. And jumbo is 16 out of 80. I can divide that by 4 over 4, which is 1 over 20. I hope you recognize that as 1/4, and this as 1/2. And we can divide this by 8 over 8. Should give us 2 over 10, which can still be reduced. Equals 1/5. That means we could have divided that by 16 in the first place. Okay, so those are all the probabilities. And now they want to ask us a little bit more about the movie theater popcorn. If the theater has 260 customers for the second show, predict how many containers of each size popcorn will be sold based on the purchases during the first show. Whoops, I should have kept my answers. So the number of small containers sold, small was 4 out of 80, which was 1/20th. But this time, not 80 people, but 260. So you can just use your calculator for that. You just put in 1 fraction key 20 times 260, and that equals 13. In math, of means times. Okay, so the medium containers, I believe that was 1/4. Let's look. The medium containers was 20 out of 80, which is 1/4. 1/4 of 260. And again, in your calculator, 1 fraction key 4 times 260 equals 65. Okay, and then the large containers, that was 1/2 of 260. And that's 130. We shouldn't need any calculator for that. And the jumbos, what was that one? The jumbos were 16 out of 80, which was 1/5. And you can put that in 1 fraction key 5 times 260 should equal 52. Now, if you were to add up all those numbers, 13, 65, 130, and 52, what should they add up to? Well, they should add up to this 260, so I feel like maybe we made a mistake here, so I'm going to go ahead and add them up. 13 plus 65 plus 130 plus 52 does indeed equal 260, so we've got them all accounted for. All right, we're going to work number 10 in this space down here. The class president made 75 copies of the flyer advertising the school play. It was found that 6 of the copies were defective. What is the probability that a flyer will be printed properly? So the defective ones would be 6 out of 75 for the bad ones. So the good ones, 6 out of 75, sorry. So if 6 of them are bad, how many of them are good? Well, 75 minus 6 would be 69 out of 75 were good. Now, can that be reduced? It sure looks like it to me because I think there's a factor of 3 in there. But you can use your calculator for that. You put in 69 fraction key 75 equals, and it comes out to 23 over 25 is the probability that a flyer will be printed properly. Okay. All right, let's look at number 11. If 400 more flyers must be printed, predict how many will be defective. Okay, so 23 out of 25 were good. So that means 2 out of 25 were bad. So if we're printing 400, it's going to be 2/25 of 400, which is 2/25 times 400. So 2 fraction key 25 times 400 equals 32 flyers. And let's double check. Yeah, they wanted to know how many would be defective. Now, some of you, I'm hoping, would not need to use your calculator. How many 25s are in 400? Well, there are 16 25s in there, 4 for each 100. And 2 out of every 25, if you multiply the 2 times the 16, you'd have 32 flyers. It's okay if you use your calculator on that, but it's good if you learn how to do some of that mentally also.